Okay, and welcome to this tutorial. This is going to focus on the inverse cosine. I expect that you have already watched the tutorial on the inverse sine. If you have not already done so, please go back and watch that one. This is going to go a little bit faster since you have already watched the inverse sine, and it'll look very similar to that, except that obviously we're talking about cosine. We're going to start with the graph of cosine. I'll mark my axes the way that I normally would. And cosine starts at 1, goes to 0, goes to -1, 0, and then 1. There's your basic cosine curve. If I continue this pattern just to look at the rest of the graph, or some more of the graph, I guess. Impossible to look at the rest of the graph. Goes on forever. There's our cosine. Again, this is not one-to-one because it fails a horizontal line test infinitely, but mathematicians decided to take this piece of the cosine function because this piece will be one-to-one. It's important to have a one-to-one piece so that we all have only one answer. This piece is one-to-one. Notice that this time our angles go from 0 to pi. Okay, the symbols are the same in that it is a little -1 up in the exponent, or you can use the arc. And yes, there are two C's in arc cosine. So either one of those is the same. And again, what that means is y is the angle whose cosine is x this time. So it's the same sort of thing. I'm going to give you a value from the unit circle, and you're going to give me the angle where that value would happen. So let's talk about the unit circle, and let's see unit circle-wise where we're talking. We are talking from 0 to pi. Some people call these the earmuffs. I guess that makes sense with such cold weather. The earmuffs, or maybe the headphones. This is where inverse cosine values will be. All the positive angles from 0 to pi. Okay, or one last little way, inverse cosine is in between 0 pi and pi. Any other angles outside of this little bubble would not be acceptable answers. Okay, let's look at a few problems with inverse cosine. So we've got inverse cosine square root of 2 over 2. Again, this should ring a bell. That's from your unit circle that you've been practicing, and I would continue to do that since we have a quiz on that. Let's do our unit circle, and square root of 2 over 2. First of all, cosine goes left and right. It's the x coordinate, so we're talking left and right. Positive would force me to the right, and the square root of 2 over 2 is the one that's right in the middle. So these are the two angles on our unit circle that would force us to go to the right, square root of 2 over 2. Instantly, one of those is x'd out because that doesn't make any sense. We're not in the inverse cosine, we're not in the bottom of the unit circle. We're always in the top, and that's exactly where we are, pi over 4. This lesson is very difficult if you do not know that unit circle, so please make sure you know that. Okay, arc cosine of -1. It's the same symbol, or the same meaning as inverse cosine of -1. So let's draw our little picture. Some people are just looking at their unit circles at this point. That's fine. -1 would force us to go all the way to the left to this angle right here. And that's the only possibility, and that's called pi. And finally, I love this problem right here. A lot of people are stumped by this, so let's really talk about this. Notice that this is the inverse cosine. Inverse cosine of pi. Now, a lot of people say, oh, I know what the cosine of pi is. The cosine of pi is -1, and they say -1, yay. That's not what we're doing. We're not taking the cosine of pi. We're taking the inverse cosine of pi. I want to know where on the unit circle is the cosine equal to pi. Well, now that might be confusing because the biggest that cosine could possibly be is 1. This is 1 right here. Where would pi be? Well, pi is about 3.14. 3.14 would be somewhere, I don't know, out here. That doesn't make any sense for the same reason why that inverse sine of 2 in the previous tutorial doesn't make any sense. This does not exist because inverse cosine along with inverse sine, the biggest number that we can have right here is 1. 1 on the inverse cosine and 1 on the inverse sine. We can't get any higher than that. So don't let this be tricky to you. This is actually not an angle. It's just the number 3.14, 159265358979323384626. And I could keep going, but I don't know anymore. So this is a number that's bigger than 1. That's all you need to know. Pi is bigger than 1. So that's no good. So it does not exist. Thanks for watching this tutorial, and I'll see you in the inverse tangent tutorial next.